Good afternoon. My name is Ali Kujuri. I'm one of the organizers of this lecture series. This is the 11th lecture in this academic year. And we're going to have one more lecture on the 28th of April, which is in fact titled WDM Transport Networks by Scott Paddles. He's the VP of Engineering Synoptics. Before we start the talk, let me first of all thank Agilent Technologies, which has been sponsoring this lecture series since the start in 2006. For today, we have a very good presentation titled Power Optimized Solar Panels, PV Systems, Where is the Value? By Mr. Kamran Shamswari, CEO of and President of Xandex. Mr. Kamran Shamswari is the CEO of Xandex Incorporated, headquartered in Petaluma, California, that offers assistance and seasoned resources for business development, engineering, and manufacturing. Xandex also develops products and offers services to worldwide customer bases in the solar energy and the semiconductor equipment markets. Xandex Solar and Xandex Semiconductor divisions service customers in their respective markets throughout North America, Asia, and the EU. That's the European Union. Mr. Shamswari holds BS degree in Mechanical Engineering from Cornell University, Master of Science degree in Mechanical Engineering from MIT, and MBA from Harvard Business School. Well, you cannot beat it, of course. Yeah. Mr. Shamswari has been a great support for the Engineering Science Department. In fact, he was one of the community leaders to start the master's program in this department. And then in fact, especially when he was the representative of North Bay Technical Roundtable, he has been a great support morally and financially to start the program. And we really appreciate all his help. So here is Mr. Kamran Shamswari.
Thank you very much. Yes, can everyone hear me? Is that loud enough? I have a tendency to just drop my voice a little bit. If you see that, just please wave your arm a little bit and bring up the decibel. Okay, it's a great pleasure to be here. Thanks for coming to listen to this talk, and thanks for giving me the opportunity to share Xandex's experience in this emerging market segment in the solar industry. We have from Fortune 500 electronics components manufacturers such as Texas Instruments, National Semiconductors, to Silicon Valley startups who have entered this market over the past 4 to 5 years, and with offers that all of their offerings essentially provides an opportunity to optimize power harvesting of the solar systems. And they believe because of this opportunity, there is a tangible value for system owners to be had. And we're going to talk about and review that and see where we are and how true that is. But before I delve into this question of the value to system owners, it would be helpful to share with you some of the solar market costs and trends, so give you an idea, a context as where the market is and what kind of a vibrant and dynamic market we have here in the solar industry. For those of you who are not familiar with Xandex, if you allow me to make a brief company introduction, I think maybe that will be also helpful. Of course, we are a California company headquartered in Sonoma County out of Petaluma. And we are a well-established private company with its roots in semiconductor test and assembly equipment market. Also, we do business worldwide, both directly and through distributors with all the major semiconductor manufacturers, most of the major semiconductor manufacturers around the world. And our customers include all the major semiconductor companies as well as some solar companies. We moved to Sonoma County about 25 years ago. We've been involved in local community and have been supportive of the high technology business development in this county. And also been glad to have been able to contribute to engineering program at Sonoma State University. Xandex is financially extremely healthy. We have a very long track record of profitability operations. We have been successful in identifying and serving profitable niche markets in the industry. Approximately 4 years ago, we started the solar division at Xandex, and the products of that division are offered to the market under the brand name Sunmiser. Xandex manufactures all of its products in the United States. It's headquartered in Petaluma, California. We have only one facility. In that facility, we don't do a lot of heavy manufacturing. We do mostly a lot of design, and then we have fabrication done by suppliers outside, and then we do mostly assembly and test. That's the model, manufacturing model. We have nearby in a lot there set up a solar lab. Reliability testing and performance evaluation in natural condition is done in our solar lab. The lab is equipped with data logging instrumentation, communication equipment, and we perform reliability assessment on various products, as we want to use them, as well as we use them for our own product development. We have a solid quality heritage built on best practices and continuous improvement philosophy. Okay, let's go and take a very quick look at the global PV market, photovoltaic market. Global market in last year, 2010, the capacity added to the installed base was about 18 gigawatts of capacity, of solar power that was added. That was a significant growth compared to 2009. In 2009, it was about 7.5, and you can see it's more than doubled. Actually, the industry if you look at the last 9-10 years, has been growing at about compounded 50 to 60%, in terms of the new capacity addition, which is a significant growth rate. And that pie chart shows you that Germany also, as you have most likely heard, dominates the market. 40% of the added capacity was placed in Germany. And of course, Italy has been coming on very strongly. They're up to about 4 gigawatts of capacity add. They're number 2 in the world. And you can see the United States got a small share, 5%. The market, just for information, for this year, 2011, is expected to get up to about 22 to 25 gig from 18 in terms of the new capacity adds, about a 40-45% growth. And when you add up all the capacity installed in European, in EU, that amounts to about 80% of the capacity is added, worldwide. A lot of these panels, which is the major component, is being made in Asia. Probably about 60% of 70% of the panels are made in Asia, but as you can see, 80% of them are installed in Europe. Just give you a sense for what's going on. Well, let's look at what's happening in our market, in the U.S. market. U.S. market, in the U.S. last year, in 2010, we installed about less than 1 gig. We installed about 800 and close to 900 megawatts of capacity here. And it was a nice growth because it more than doubled, almost doubled, the capacity that we put in use in 2009. There are 3 major markets for solar. It's a residential market, it's a commercial industrial market, businesses and industry, and then the utility scale market. And these are these huge fields that utility companies install, and basically the power is sold to them. And then they bring it into the grid. The utility market is a huge market, and it had a significant growth. It accounted for about 1/4, 25% of the capacity that was added in 2010 was in the utility area. So that market has come down very strong. It will continue to play a very important role, a big role in the future growth of the solar. It's a tough market. It's very price competitive. But nevertheless, it's got the momentum behind it in terms of that all the states are setting these renewable energy standards, percentage of the energy that has to be produced from the renewable sources, which has this basically helps solar quite a bit. So utilities are very keen. Now again, this point of reference for this year, the market in the United States could grow to be as large as 2 gigawatts. So you're going from under gigawatt, close to 1 gigawatt, to about over 2 gigawatts of capacity that's going to be added. And that's why you see all this activity with various installer companies and announcements and in the market. Also, it's important so once you see a market and get a sense for it, well, of course, the important thing is that what is the PV cost? You've all have heard that PV is too expensive. It relies on incentives. There has to be incentives. And luckily, we are in California. We're very fortunate to have led the way in the United States in terms of providing incentives for solar installations. And California accounts for about 60% of the installed solar in the United States, roughly. So, but the cost is still a problem with this alternative. And if you want to understand the monetary value of the new technology that's going to be added to the solar, we need to understand the monetary value of the installed solar system to begin with first, and then see, okay, how can we impact that? How can we improve that? So this is a summary of what goes on at a very high level. The total system cost can be broken down into three buckets. Of course, you got the module is the biggest bucket, and then the inverter. That's where all the technology, power electronics technology is being developed and offered. That's where the action is. That's the market we'll be talking about. It's related to the inverter, power conversion and optimization. And then you can put all the other activity, which is some material, the wirings and connections, as well as labor to install it, plus the overhead of doing business and everything all together, call it the balance of system, all into that one bucket. That's about 35%. Now, if you look at this table, it gives you an idea of, in terms of the dollars and cents that we're talking about. You see the percentages. Sometimes it's difficult to relate to what we're talking about. These days, the residential markets, you can probably get $6 to $7, systems before incentives, And for commercial, you can go to as low as like $5 per watt, that is installed. And what I'd like to bring to your attention is that the inverter, as you can see, is only 50 to 60 cents of this cost, So what we are talking about here in trying to introduce electronics, add electronics to this pie, it all depends on, okay, at what cost? What are you adding to the 60 cents? How are you impacting it, and what are you getting for it? Therefore, where is the value?
So those are included in the 6 to 7.
I'm sorry?
The solar modules and inverter and balance of
system.
All of that is
add up to the,
okay.
You roll that up, it goes to 6 to 7
6 to
or
$7.
$5.
Yeah.
Those are the three buckets. But it showed then Now you can see the major component. Now the question is that, okay, what is the trend? As you're developing products, new technologies, you introduce them, it takes time. It takes 18 months, 24 months to develop products, introduce them. It takes another, sometimes up to 2 years to really get the adoption going of those products. So you're looking at, by the time you decide I'm going to do something, you're not going to be out there really selling it maybe up to 2 years, or so from now. So the world will be changed. It's very important that you look at the trend so you don't make your decision based on today's world, project and see what the world's going to be in 2 years from now, so you're designing for that, obviously, type of thing. So what is the trends, dominant trends that's going on? Of course, we're going to start with the biggest piece, which is the panel. And if you look at the price of panel, this shows a decade of pricing here. Solar Buzz, you can go online, and they have all kinds of, there's a lot of good information for those of you who are interested, in regard to all kinds of statistics about pricing and market and everything. It's a good site, to go and learn more. But that chart's essentially, since, mid-2000, price remained high and in the mid-decade, it's kind of stabilized. And that was the period where a lot of capacity started being added to the mix, particularly in Asia. Multiple Chinese companies started entering the market. Taiwanese companies followed them. And just recently now the Korean companies, Samsung and Hyundai, has also entered the market. So all the big Chinese players are well into this market. There are about maybe 200 to about 500 manufacturers of solar panels these days. The industry, no doubt, will go through consolidation. I can see, like any other industry. It's a new industry, as you can see, so there's a lot that's happening. It's a wild, wild west in some ways. But it's a lot of opportunities as a result, a lot of good things happening, a lot of excitement. But as you can see, that once the capacity hit, the prices start falling down significantly. And it's got to a point where it's this situation, you can see this drop is reflective of commodity type pricing. So for all practical purposes, everybody considers panel as a commodity right now. And the price continues to fall about 7 to 10% every year still. Interesting.
And now, this is now for the panel, right?
Yeah, this is the end user price for the panel.
And then to that, the numbers that you had in the previous chart.
Right, this is just the panel part of it. This is just the panel part of it. That's the 55% portion. So price was $550 at the time. Price stabilized, capacity was added, and now we are down at about $330 in early 2000. You see a significant drop, and still supply is keeping ahead of the demand. So that's why the prices keep continuing to go down. Okay, hope we give you a general idea of what the business is, how vibrant it is, what the size is, what are the trends in the dominant trends, what are the costs, and what are the piece that we're talking about, what role does it play? It's about a 10% cost adder, basically to get the job done. And the job, okay, then what is the job? To understand what these new product class are meant to do to accomplish in the market, we need to look at the technology of how solar modules convert the DC power that is generated in the module into an AC, which is the work of an inverter. That's done. So for that, I'm going to talk about power point tracking or maximum power point tracking. And fundamentally, you got a continuously changing conditions with the sun, and the intensity of the sun and how much photon you have to convert. And the role of the inverter is to continuously adjust the current and voltage to these continuously changing conditions and put it at a point where it's the maximum output. You get the maximum wattage out of that. Okay, let's look at this is a typical IV curve. As you can see that there's a current here and a voltage, and then we have the power. So this is the current and voltage. And then this is the multiplication of the current and voltage, the wattage, power. So this is like shown at the 3 different illumination levels. Level of, it tells you about the amount of illumination per meter squared. That's how it's measured. And as you can see, as it drops and changes, the power, if you look at the power point, you look at the knee of that curve, you see that starts shifting, moving around. So the inverter continuously searches and looks for this voltage and current and make the adjustments by changing the resistance, inductance, and then finding the optimal point here. That's the job of the inverter, and it does it on a system level. It looks at the output of all the panels, collectively, and does this job.
So does that mean throughout the day, it's going to be trying to get the most power for you?
At any point during the day, it tries to get the maximum power for you, yeah. But the power, that maximum power varies a lot. It's directly dependent on how much sunlight you have, obviously, because that's the fuel. That's the fuel that you're converting. Essentially, it's just like having the. Are you going to have coal and gas to run a gas, for example, power plant or not? When there's no gas, there's no activity, right? So there's no sunlight. But it adjusts to that levels because at that level, when the photon hits the solar panel, it basically changes the current for you, right? And the more intense it is, the more current it produces. So as the intensity changes, the current continuously changes, and then that changes the voltage. So you get this dynamic thing going all the time. And what the inverter does through this algorithm, the MPPT software algorithm, it continuously searches and probes and adjusts, and then finally settles on what it determines is the best point, is the maximum power harvesting point.
Yeah. Can I ask you a question now? Yeah.
Another company in Petaluma, Enphase, makes those inverters. Is that what they are doing in there?
Right, they're taking the inverters that I'm referring to here are, which is very common, are central inverters. So you just get one inverter for the whole system. What Enphase is doing, and I'll show you some other companies, they have developed inverter per panel. So you can do the basically optimization and conversion at the same time per each panel. That way you take panels independency out of the picture, basically.
I see. Thank you.
That's kind of
now here, when you are talking about it's going to optimize the thing, is it the combination of the panel and the battery that basically stores this thing now, or just the panel itself? How is it optimized now here?
These systems generally don't have battery backup. 90% of the system don't have battery backup that you install in your homes or commercials and things like that. Certain big installations are beginning to look at storage, and storage is another Achilles heel of any kind of a renewable that is intermittent. Sun is not there, you're not producing anything, or at night you're not producing anything. So if you have a utility and you're counting on that power to serve your customers, it's going to be intermittent. You can just imagine what kind of a heartache it's going to create for you. So having a reliable storage and costly storage option available to you is a must. Is something that's going to be needed for this thing to really make it work effectively into the mix of energy sources for the utilities. But these don't have power. So the way it works is basically just through the inductance. It has through the electronics, just look at that and starts, creating resistance, change basically the current to see how you're basically. Oops.
So you're matching the source impedance and load impedance.
Yes, right, exactly. Yeah. Oops. Let's see.
I can read for you. Shall I go?
No, I'm just clicking the thing instead of laser, but it's my mistake. Operator's error. No, I just wanted to be done that. No, the chart that I was in.
Okay.
No, if you go forward, please.
Okay, forward, no problem.
There we go. And more, you can go through and another one.
Another one?
Yes, and another one, please. Basically, what the inverter is does, it's just kept by changing the inductance. It's basically changing your current and voltage, and then you start basically hovering this line around here. So if you go too past, too much past of it, it looks behind. So, oh, the current is lower. That's not a good point. So it goes backs off. So it continuously basically plays that game until it settles at at the maximum point.
Yeah.
The whole MPPT software in itself is primarily the IP of a lot of these inverter companies. Everybody does it, tweaks it differently, and it's got its own trick. And it's fundamentally that's where a lot of the secret sauce lies. The hardware part of the inverter is pretty straightforward. The components that are used and what grade and how reliable you want it to be and everything. But the software side of it is the tricky part.
But it's the principle of it, isn't it that you look at the multiplication of I and V and you maximize that, and that could be represented by the area under
Essentially, that's correct. But to decide where to end up, where to settle, and let basically the system settle, that process is all through the software algorithm.
Very interesting.
Done by the inverter. Okay, power optimization and DC-AC inversions at the panel level has been tried before many years, about maybe 15, 10, 12 years ago in Europe, where they're way ahead of us, United States, in solar. And at the time, because of the available technology at the time, the pricing structure and reliability issues, it was not pursued. It was attempted, a couple products came out, and then was put to bed. Then, back in 2005, 2006, in the United States, a lot of the startup companies starts coming, into the market, as well as some of the large established semiconductor companies start coming to the market, who have expertise in designing power electronics, chips. And the startups also were done by people from the semiconductor industry with power electronics background or communication background. It's basically as a chip play, it's a chip game, as well, at the end of the day when you look at it. And so what they all do, what are some of the things that they have in common, okay? As I said, they entered the market, they start developing in about 05 or so, but it took about 2-3 years before the products were ready. 2008, the products entered the market. What do they essentially do? What do they try to do? How do they want to change the picture? Is that they're taking the function that I just described to you, maximum power point tracking, rather than doing it centrally in one unit, central unit, they try to distribute that function per panel. And by doing that, you're going to maximize each panel's output, irrespective of the other panels. And that in itself has got value, essentially. Second thing that they do is that they provide information. Since they reside with each panel, they can, and then they look at the power and then optimize power or convert power. They have a lot of information that they can send to you. So either wirelessly or through the power line communication. Communication through the power line. There are standards for both of those methodologies for communication. And they use one of the two methods, one or the other, to communicate and give basically performance and power generation information to the user, to the system owner, per panel. Right now you can learn and know how your system is doing, but it's all at the system level. The central inverter can give you that information. This gives you another layer of granularity. You can see each panel what it's doing, and that, we have to find out what the eventual use or value of that is. I mean, it's a nice thing, but it's appealing. It's got sex appeal or advantage for people.
But after all, isn't it that we want to sum up the output of these panels and then go to the grid or wherever?
Yes.
And then, so this means that the total should be maximized rather than the individual one? How is it?
Well, when you do it on a system level, there is a lot of dependencies between depending on how they're wired together, there's a lot of dependency between the panel. When you go and do it individually, you take away that dependency, and that dependency sometimes hurts you. Like if one panel is shaded or degraded and is in series tied to the other panels, 5 or 6 other panels, those are 5 or 6 other panels go down to the performance levels of the one that is degraded.
Okay.
So when you're doing, and the role of the inverter is to kind of figure all that out, and then there are other electronics I talked to you a little bit about that come into play. But fundamentally, when you go and do that individually, you take that dependency out and you get a gain, net gain.
So you throw that one out.
Yeah.
Okay.
So if you have one weak link of amongst, let's say, 20 panels, it's concentrated. The other 19 panels can perform at this maximum output.
What is the impact on cost?
Right, we'll get there. Yes, that's the whole. And some of these products provide opportunities. You remember the third pie that I said? There was a panel, inverter, and a balance of system, everything else, let's call it. And some of the products opportunities provide opportunities to reduce cost, some in material, some in design, considerations. It would be easier to design your system with some of these products. And some have labor savings in terms of assembly. So there are some claims about a little bit of a saving on the side from the balance of system.
Does it matter particularly the size of the installation, total installation, whether the inverter system based on the individual panels versus the whole installation becomes more practical?
Right now, the state of the industry is that it's most suitable for smaller installation, like primarily residential type installation. But the industry is working really hard to get out of that mode and then get into a much larger installation, because as you understand, that's where the volume is compared to the residential. A typical residential home may have 16 panels, 20 panels, so some of them maybe have 8 or 10 panels, the smaller homes. But of course, you go to a commercial, then you also have like about 600 panels or 500 panels. And you go to larger ones, sometimes a couple thousand panels, So it takes a lot of homes to get up to one of those installations. You get one order like that, that's a lot of sales for you. So let's look at what are these products now that do all these good things I'm supposed to do, and give you some examples of some of them. Micro-inverters is one class. Essentially, it replaces the central inverter. Not only it performs the MPPT, maximum power point tracking, to maximize the energy harvest. It takes that DC power, the current, and then convert it to the AC so it can use it in the house, basically for normal use. So it does that on an individual per panel basis.
So what does it make this one micro? Is it because it's just per panel? Or
yeah, they just call it it's like they could call it a mini inverter too. I don't know. They go from inverter. They decide to skip mini, just go to micro. So you get inverter, mini inverter, micro inverter. So that's a term that's usually used. Basically, it's just going to per panel. Yeah. Enphase is a Petaluma-based company. It's the leader in this area. It's one of the first that came up with the products, commercially viable products, and they have been raised 2-3 rounds of funds. I think they've raised over $100 million so far, which gives you an idea of how capital intensive these type of industries are when you come up with a new product. Especially keep in mind, these are the type of products that are outside in harsh environment, snow, cold, heat, all that, and are expected to last 15, 20 years type of a thing. So if you come up with electronics and says, don't worry, just put it up there on your roof with your panels, I mean, you have to have a big leap of faith, to want to just take that and put it there and say, okay, everything is, I know it's going to work for 15 years, 10 years. So to overcome that, and that's a lot of inertia here that you need to overcome, and then that's the whole adoption chasm that a lot of small companies can't survive. They just get buried and they never make it out the other end. And that's why it takes a lot of money too, like the Enphase has. But let's go look at there's an example here from Europe that's out of Cambridge, UK. This is Nexus is another one. And this is one from China, Involar, out of Shanghai. And you get the picture now. You see we started it here, now the European are, and after European, as you can see, UK, which is not a big player, they're more entrepreneurial, a little bit closer to the American mentality and everything they started, and of course the Chinese never fall behind, they always get into the action. So they're all here. Now, look at the DC power optimizer. DC power optimizer, and basically, they just do optimization. They just do the MPPT tracking. And they are, for those of you who may know about power optimization and tracking and everything, these are some of the, using the buck and boost and buck and boost. These are all well-known, established methodologies of power management. It's used in everywhere, consumer electronics and everywhere, computers and servers. And so power optimization has been around for a long time. A lot of good companies were making that. And these are typical technologies that are used. National Semiconductor came up with their box. In the US, this box has since been pulled out of the market. They've come in with a chipset. I'll talk to you a little bit later. Tigo Energy is another startup. It's an Israeli-based company. A lot of the engineering is done out of Israel. They come from out of Intel Israel. And of course, most famous one out of Petaluma here is Xandex. We also did our first product, first entry. This was an internal development that we did. We launched this product. It was slightly different than other products in that the topology that we chose was to, because of cost reasons, we did not make a box that you need to put it on every panel. We just made a box that you're going to put it only on selective panels, and those are the panels that are most impaired, that have the most potential to get shaded and so on and so forth in an installation. So we were an only limited deployment company, that were there for cost reasons. But we did one thing really, really well and cost effectively, but the market needed more. They were not that enamored with that. It's okay, that's fine. I don't know how to interpret that. What am I going to get out of it? What else do you have for me? And I want to be on everything. And that's where we could not compete. We did not have that offering. We pulled this product out of the market, and then we re-entering the market with a different product at a system level, not on a component level. Just FYI. But it was a great, learning experience. It was costly as well too, but things happen like that. And probably you have a lot of stories about how many Agilent projects at that phase. And there is a unique offering here by this company, which what they have done, their product essentially takes the central box and they made it simpler. They took a lot of the electronics that has to do with maximum power point tracking out of it, made it a very basic, and its function is to just connect to the power grid. Because the power grid goes through a lot of changes all the time and everything like that. So you need a buffer here to see that and manage that and don't mess things up. The utilities are very critical about that. So they kept that piece, but they take all the other electronics and then put it in an ASIC, application-specific IC, specific, and their power optimization boxes are on that basis that you can see. Solar Edge is a venture-backed company also, and they term their implementation a comprehensive solution. Go ahead, please.
Yeah, I have a good question. You were saying that you manufacture the DC power optimizers. And
yes.
What basically it does? If the panel got shaded, then what's the purpose of that optimizer?
Typically, when the panel gets shaded, the current, it becomes like a current sink. So every current that produced with everywhere else in that line, gets absorbed and then taken, and it goes into like a defective cell, and it makes the cell hot, and if it continues, actually burns the whole thing. So you have little diodes that shuts this off, prevents that. So that's right now the current system. Now, when you put our box in it, when that panel gets disabled, it essentially shields it from the rest of the system. It's just like it doesn't exist. However, it's keep checking what the current is on the line, and it starts doing the MPPT, just playing around with the voltage and current and the constant current, and then try to put a current that matches the current that is on the line, so it doesn't become a sink. And then when it reaches that point, then whatever power that is might be, you might have a 200-watt panel, but because light is not there, it's just good as like a 50-watt panel. So you just extract that 50 watt and gradually feeds it into the line. So you get that power back without impairing performance of everything else.
But it usually affects because we usually count the number of panels we need for a particular system.
Right.
If we shut off one panel, then it means.
Well, if you have situation where it's systemic, and for a long period of time, you shouldn't even put panel there. It's like opening up a factory and saying I'm next to this source and gas, but I have gas for only 2 hours. I'm going to build this multi-million-dollar factory, even though I have 2 hours of gas. You're just not going to make the factory because you have only 2 hours of gas. So if you're in a position where you get a lot of shade, you don't even put panels there. In fact, there's some countries like Japan, for their incentives, if you have any panels on your roof that goes into a shade, they don't even reimburse you for it. It doesn't even count. So that's the extreme. So the situation we're talking about are the dynamic situation and the things that may happen systematic, but for a short period of time. Maybe an hour and a half, in a certain time, afternoon or so, shade happens. And there lies the challenge. Because if the system is really bad all the time, then why are you even having solar? You don't need to even install. So you don't need electronics. I mean, it's already broken. I mean, it's just not helping anything. But if it's not, it's marginal, it's here and there and everything, then the question is, well, what am I net after all? What am I getting here? Because it's not. I don't need to optimize continuously. I optimize an hour here. I don't have to optimize 2 days. Then I do another one. That's the challenge, basically, of this class right now. So let's talk about the challenge. I think that's the segue into going about the challenges here. There are 3 fronts of the performance, of course: cost and the reliability. Not a big surprise, I hope, for everybody. And let's talk about the performance challenge. As far as performance goes, we're dealing with power electronics, right? We're talking about electronics. Electronics require the power to work. So these boxes by themselves consume some power. Some of them are consuming about 2-3 watts of power. So that is a hit that you're going to get. That usually, and then also in the conversion, as you take the electrons and you do stuff on them and pass them along again, there's always a hit. There's always an efficiency involved here. Can't get it for free, right? So just the fact that they consume power and the activities that they do, it creates basically a yield hit. You need about 1.5 to 3% efficiency hit. So the optimization, whatever extra you want to get, first it has to address that, fill this, what you lost, and then above and beyond that, see what you can get. So what you can get, in most cases, is about 4%. Actually, it's under 4%. You might hear here and there in the industry or read that people claim, well, 10%, 50%, 25%, recovery and this and that. Those are all corner cases, or maybe for an hour, the situation was really bad and electronics really helped you during that 1 hour. But those are not, kind of an overall claims that you can do. Right now, these products have been in the market for 3 years. There's a bunch of data. We have introduced data. We had installations. We look at our competitors. The industry consensus is that, okay, yeah, 3-4%, under 4% is doable. Most likely is doable. Now, the other problem is that, of course, scaling up to larger arrays, and these are the large arrays on, let's say on like a Costco roof, or a Kohl's roof, or in an industrial area, they have it on the ground. Those large arrays are hesitant, to use these products. So there is not enough, because there's not enough field-proven data here. Now, at the same time, the larger installations, since they're generally in open areas and fields and everything, are a lot less susceptible to this shading and various elements that impairs the performance of the panels that are more common, let's say maybe on a house, on a roof, on a residential roof. So even there's less to have. So you go in there with a 1.5–3% hit, you don't have much, you might end up come back empty-handed. We have seen cases where they actually have an adverse effect sometimes. They take a 1% away, and when you look at your output over a period of time. So what's the cost challenge? These products, of course, are not cheap. You know, they have to cost something. And what's the cost? In today's market, the cost hit to the end user is about 20-25 cents. If you remember the inverter numbers, you remember we talked about the inverter numbers were about 60, 60 cents, if you remember. So just imagine if you want to get a 20 cents premium hit. So what are you getting for it? You know, you really, it's a significant up, you know, from 60 cents to, you know, 80 cents, you know, 20 cents more, a third. That could be significant. If you look at the annual value of the power that you're going to get out of, and I made this calculation only on just putting 1 watt. Just imagine, typical panel has 200 watts. Let's look at the 1 watt that goes in there. You do a panel, it's 200 watts. You know, every watt of that will have a 20 cents extra. So for the 200 watt panel, you get about $40 extra hit on your panel, you know, kind of a thing, to give you an idea. These boxes will be about $40 that you buy. But you look at that 4% that I tell you, you know, and you look at in Northern California, where we are, if you installed 1 watt, how much production you're going to get out of it, and if you were to get 4% more, what's the value of that 4% more at retail, you know, utility prices, the prices, the bills that you pay, which in California is about 17 cents on average. You all get your bills, you know, you see the tiered pricing that can go up to about 33, 35 cents and stuff like that, but it starts sometimes at 11, 12, and there's peak and there's all these. But when you look at all that on an average, you know, California is about 17 cents, you know, they say is the power, cost of the power, utility that you pay. So if you take that 17 cents, you look at that 4% extra you get, and you do the annual, it amounts to about 1 penny. So if you want to get that 20 cents paid back, I mean, it's just, the payback is just way too long. It's not acceptable.
How much power would each micro-inverter is handling? I mean, what's the assumption here?
It handles about 200 watts. Basically, it works with, which is one panel. Yeah, 200 to 240 watts, 30 watts.
Okay.
But the idea is that there's some. The rule of thumb is that every watt that you install, you will get so many kilowatt hours per year out of it. And depending on where you are, it changes. Of course, sunny areas you can get up to 2 kilowatt hours. That's our consumption for the year. If you just put 1 watt, it gives you about 2 kilowatt hours per year. California, where we are, is about 1.5. And you go to, let's say, Germany and everything, the number falls down to under 1 kilowatt hours. So if you say I get 1.5 kilowatt hours at every watt, if I use these electronics, I'm going to get 4% more. Well, what's 4% of 1.5? And you multiply that by 17 cents and everything, that's your 1 penny, basically. So I'm paying 20 cents to get something, and I'm going to get every year only a penny for it. It's going to take a long time before, in 20 years, I'm not going to be happy. It just doesn't, you know, from an economics point of view, it just doesn't compute yet. Okay, then what's the reliability challenge here? More electronics in harsh environment. Typical panel comes with 3 to 4 diodes. Diodes is a very straightforward commodity, simple pricing, and you can get them all depending on cost with different reliability levels, you know, for industrial grade, for military grade, and so on and so forth. They're using reasonable diodes. It's the simplest, cheapest thing. Now, when you inside one of those boxes, they're anywhere from 80, actually I should say 100, to sometimes about 180 unique parts, unique electronic parts. And of some of these unique parts, you got a few, so your total part counts could go up as high as about 250, you know, 180 or so parts. Of course, through circuit integration, you could combine all these components and then reduce your part counts and things like that. But that again in itself is another ASIC development. It's about $5 million, you know, and so it doesn't come cheap. But right now the state is that, so you're taking something that has 3 or 4, you know, electronic components, all of a sudden stick about 200 electronics or 180 electronics components to it, and you package it and put it on the roof and says it should be okay. Well, it's not going to be okay. We know electronics fail. We all know that, you know, kind of a thing. So that's the kind. And then, of course, the field experience is very limited. They're all new products in the market, no more than 3 years. So inverters have been around for a long time. They're known to last about 15 years. Panels are expected to last about 20, 25 years. And so the question is that with only 3 years of experience on your belt, are you sitting on a ticking bomb if you elected to choose that in your system? With at the year 7, 8, 9, what's going to happen there? Are these things starts failing, popping? You know, it's like a popcorn, and you got. What are you going to do each time you want to get somebody to come here, truck roll, and go up and change one of these? And it could be that could be a big worry. Excuse me.
What physically limits the inverter life? What fails?
The weak links are optocouplers and capacitors, electrolytic capacitors. Yeah.
Okay, thank you.
So they are now, like NX's product, for example, have gone away from electrolytic capacitors and they're using solid-state capacitors. And they go into the two-stage, basically call it inverter and everything, but you get, of course, the efficiency hit because of that. It can't be as efficient anymore, you know, kind of a thing. You know. So as you know, it's like a world of design and engineering. It's all full of trade-offs and everything like that that you haven't. Here's no different.
The maintenance of the panel, basically when it gets dirty or the dust comes on, maybe some leaves come on, that's all. That requires periodic cleaning, and then that's going to add. In fact, somebody should go up the ladder. I mean, those family who are not handy, they need to hire somebody who would have insurance on. It's going to be costly. Now, did you add that thing also into the
cost of the system? No, this is just the install cost of the system all in. The ongoing maintenance cost is not factored into that at all.
Yeah, because
into that cost,
then it's going to cost something. Yeah.
But right now, most of some people go and clean their panels or something, but the clean is a matter of just basically hosing it with the thing. And some people, or some major manufacturers even say you don't even need it. You know, if you know somewhere where it's enough rain, then you should be okay. But by looking at, that's one of the things, that having the ability to look at each panel, you can make those decisions based on that data. You can see, well, look, these are all 200 watt panels, they're all doing 150 across the board. So maybe there's something systemic, maybe there needs a wash. So you could then time it. You don't automatically go do it. But you may not need a wash for 1 year at all. 1 year you might need 2, because there's a construction going on next door and they're raising a lot of dust and trucks come and go. And, so a lot of those kind of elements come into play. And that's why I say this informatics is good. It will enable you to determine and don't limit your losses and whatnot. So as a result, you can see why there's a slow adoption rate for these products due to fear and uncertainty right now. When it comes to reliability. Of course, we talked about the cost, and we saw the performance challenges. Once you start electronics, it consumes power too, so you have to make that up and more. Is there enough? Kind of a thing. So by here, you're wondering why these guys are even selling anything. Who's buying these things with all these problems? Why do they even exist and everything? So that's if you're not asking this question, maybe I'll ask it for you if you think about it. So. Anybody has any idea why?
Subsidy.
I think the thing is the operating board probably will be the early adopters. I mean, we're great in this country, particularly being open to trying new things and jump on things, new technology. We get enamel. We try things. A lot of things starts here, and then once we develop it, it gradually goes to other markets, and sometimes it disappears. From a manufacturing point of view. So early adopters, who are they? What are they selling? They're selling. These companies are selling. They're venture funded. If they're not selling, they would be closed. They would not be in operation anymore. They managed to raise money, 1 or 2 or 3 rounds, some of them. So, they're showing results. I don't think these guys are not writing these big checks, and not knowing what they're doing, just haphazardly throwing money out. So there is hope, there is thing, and then so who's starting that? Micro-inverters is adopted mostly by the residential installer, despite of being costlier for the homeowners. And interesting is that we have had a case where a couple of our employees wanted solar, and they got quotation with microinverter and without microinverter from the supplier. The quote with microinverter was producing a little bit less and was costing more, versus the central inverter, things, because that's a proven and known methodology that's been around. So why are they using that? Because we got early adopter customers here. I don't know if you guys know that, but I said California is the biggest market here, and the residential market is very big in California. The last statistic I said there are about 100,000 homes that have solar in California. And does anybody know how many homes there are in California? That's 100,000 homes out of something like 200 million homes. Excuse me, 50 million homes. Because there are about 3 or 4 households per home and everything. So you're about 250 million and 260 million in the United States. I mean in California, and that 50 million in California, the million home, 100,000. It's only 1%. Excuse me, 10 million homes with 4 residents in there. I got my numbers a little mixed up. 40 per home, 10 million homes, so 40 million population here, only 100,000 homes. About 1% of the homes have solar on it in California. And we're supposed to be number 1. Just give you a sense of what it is. So these guys are still a lot of early adopters, I would say. People who are adopting solar these days. You look at the economics and issues and everything. So they are willing to pay the price. And these products make the life easier for some of these guys. Another interesting thing is that, to give you an idea of how many new installers are joining the ranks, the data for getting incentives from the state of California, it's called California Solar Initiative, CSI. It's administered by PG&E. And there's a lot of data available, good data as far as what system size, who's installing it, what equipments they use, and all that data is there. So if you look at that data, who the installers are. In 2008, there were probably about 300 new installers that had joined the rank. 2 years later, there were 900 installers that joined the rank. So these new guys who are coming here, this is a convenient way for them to design the system and quickly install it, and then have something to talk about that differentiate them, and then in the meantime get a little bit more money. So it works really well for them, and customers are willing to now go along with it. They like it. The informatics, as I told you, is a plus. It's a novelty, and most of the use of this product has been in the countries where the solar is growing, just emerging and then growing very rapidly. That's U.S. and in Europe would be markets like Italy, France, Czechoslovakia, those kind of markets. Now, established market, Germany and Japan have been at it with solar for 15 years plus more. Neither one of those markets are adopting, for example, microinverters. They're not touching it. They're not using it in there. And also
because maybe they have already the centralized one and they don't want to change, or
certainly that's one idea. The other one is that they don't believe that the whole value is there yet. The thing has not got to a point where it can cancel out. Sometimes if you have situations where there is impairment due to shade or anything, or if you want to add capacity, they really look at it hard and say, well, I'll just add 2 more panels. That might be even cheaper for me than try to get all these boxes, go in there, put it on all the panels, and have a new element in there, and then figure out how it's going to work or not. Don't worry, just put 2 more panels, I'll get my extra. They approach it that way too. So or like in Japan, they won't let you install in the shade. But mature market, and then the large commercial markets installations, they all need to be financed. They need financing, and it becomes a question of bankability. Banks don't want to pay money for stuff that experimental. It could cause problem. These financings are good for 15 10-year, 15-year financing. So they're long-term. It's not a 1-year financing and they're out. So they're in there stuck, you know, and the people who make these commitments, these contracts, they have to perform. So the bankability is still an issue. It's a stumbling block for this. So question is, well, these are challenges. How are we going to overcome these challenges? Of course, the cost reduction through integration is really the ultimate. You saw the pictures on there. These are all relatively heavy, bulky boxes. There's a lot of electronics in them. There's packaging in there. There are connectors. There are cables. There's a bunch of duplication. I mean, behind the panel, there are cables. There are those connectors. There is an enclosure. Everything is there. So you have taken and duplicated all of that. And then you put in a bunch of electronics, I mean, components in there, 200 or so, 150 parts in there. And how can you get away from that? Well, get rid of all the packaging and go to the chipsets and integrate it into the panel. And that's the answer. And then already, you see, National Semiconductor, as I said, has a chipset there, optimized a chipset. ST Microelectronics has one. Microchip is another power electronics component manufacturer in the United States. You know, they have also offerings. So all these semiconductor companies, like they have, we had talked to TI. You know, we had connections with TI. We're working with their development groups as far as what they are doing. And then they were saying that they consider solar. They're looking around. They haven't seen any market that is going to be as growing and as got as much potential as solar does for their chips. So they are looking at this thing to come up with the chipsets too. Everybody's waiting until it gets to a critical mass or the volumes are there, the adoption is there, you know, a little bit more, and they're going to jump in. You know, so the holy grail of this thing is take that big bulky box and then basically now integrate it. Now the question said one is that, well, what about the reliability? And I think their counter to that is that, well, look at what we have done in cars. I mean, cars, you remember, every year they get even more and more electronics in them. And they are, the automotive standards for reliability are quite high. And the environment that they operate, the cars operate, is harsh too. It's out there in dust and water and cold. And so since we have done it in electronic, and there are electronics widely used in cars, we can do it for solar panels too. And that is true, and that's somewhat believable.
Just a thought, maybe a crazy thought, but how about remote control in terms of, instead of having the instruments there, wirelessly you send information somewhere else and then the analysis is done and then the control is made. Is that something that is even remotely possible?
You still need the electronics per panel. If you want to separate the panel things, you're still stuck with that. So if you do anything centrally, you're back to the central mode. Now it's interesting that you say that, because one of the Tigo product that we send, their communication is based on wireless. So what they do, they don't do so much of their MPPT algorithm within the units. They just collect the data and then send it. So they're kind of doing, but still there's a box there. And they send that information, and they do all their calculation algorithm in a central box, and then they send a signal. So say, go there in voltage, go there in current, That's their scheme. Okay. Which is, well, that's good, but then you get big installation, you need a repeater, then you get into the wireless communication issues, and all kind of, it brings its own set of challenges.
Okay.
But a version of that, in a way, is already on the market. Tigo kind of does that. Okay, so with that, then what are you going to get for the future value of the solar electronics?